Pandas is a powerful tool for manipulating data that lends itself to the small and medium projects of budding data scientists. Join me today as we develop our understanding of data handling. Hi, I'm Gregory DataFrame with GNT Learning. On this episode, I'm going to help you understand the structure and use of Pandas data frames and series objects. All too often, new users get caught up in confusing error messages from things that look like exactly the right syntax from something they copied online, and yet it doesn't work. Today, we're going to explore the common errors to help alleviate the frustration and confusion caused as we're learning how to grab and access data inside of our data frames and series objects. We're starting off with the Jupyter Notebook, where we've gone ahead and imported Pandas PD and read in f.csv for some outside data. Now, this data actually came from Yahoo Finance and is information about the stock prices of the Ford Motor Company, ticker symbol F. We then displayed it as shown here, and we see that we have a nice little collection of data with multiple columns describing the stock. The leftmost set of values here is the index. This index goes 0, 1, 2, 3, 4, and was set by default because it wasn't part of the original data file. This index itself is a lot like the names of the columns and allows you to access the rows in the same way that column names would allow you to access the columns. By default, we can use this 0, 1, 2, 3. However, we're going to go ahead and set this to use the date column instead as our index. This is not something that is strictly necessary in general, and instead is being used as a tool to allow us to see some interesting things later on in the lesson today. To do that, we're going to go ahead and set df.setIndex on the date, and we'll go ahead and display our data frame as well. So go ahead and scroll down and do that. All right. And so we see when we do this that we get something that looks very much like the original one, except now that we have the date as no longer a normal column, instead indeed doesn't need to show up as a column, and instead is the index for our data. We should go ahead and take a moment here and do a little bit of evaluation to make sure things are going okay, and we'll use df.info to give us information about the system. Now we're going to have an interesting little error when I run this. And the error we're going to get is that date is not a column. Now this is a very common type of error that you see when people are working with data frames and manipulating them in place. I never use the in place keyword. We'll talk about that more another time. Instead, I took the data frame, I did something to it, and I assigned it back to its original name. This means I overwrote the original data frame. This one, shown here, doesn't exist in memory anymore. Instead, the one I created with the date column as the index is the one that existed, which meant that when I tried to run setIndex again, the date column no longer existed as a column, and so it crashed out. So you need to be careful when you're running multiple cells in a data frame, or rather a Jupyter Notebook on a data frame, that you might change the structure of the system as you go if you're using the same variable names. You either need to have care about the order in which you run things, or you need to use different variable names as you go through so you don't run into this issue. For this one, I like the df variable name, so I'm going to go ahead and just rerun this. I can either do this manually or automatically. I'm going to go ahead and just do this automatically. If I restart and run all, where I restart and run all of the cells. Now, having done this, I can now turn to what I originally intended to do, which was use df.info in order to examine what is going on with our new data frame. So here we see a couple of useful pieces of information. First, we get a nice description of all the columns in the data. In this case, we have few enough columns that we could see them clearly in our original display, but if we had too many columns, we could actually see all of the columns here listed out nicely. Second, we can see how many non-null values there are. The main key point here is that we want to see if there's any missing data, something that isn't the same number as the total number of rows in the data frame. Right? In this case, we don't have any missing values. And as we can see the D type to see how the system is interpreting all these different things when it read them in from file. For the most part, Pandas will do a pretty good job with well-formatted data, though sometimes it will have anomalous data and then it will give you a different data type than you expect. Now, the full range of debugging activities and cleaning up of data beyond the scope of our lesson today. However, it is always good practice before you dive into a set of data to make sure it looks right. Since we couldn't see every single value directly when we looked at the display on DF, we wanted to go ahead and look at the .info to make sure that there wasn't something weird going on. Turns out this is a nice complete set of data, so we can go ahead and move on with where our actual interest is today. Now, we can go ahead and access data from our data frame in a lot of different ways, and the most basic one we're going to start with today is using square brackets around the name of a column. This allows us to grab one column's worth of information from the data frame. And here I want to highlight that we use quotes around the name because the name itself is a string. Even though our visualizations above didn't put those quotes there, these are actually strings for names of columns. Technically speaking, data frame columns can be other object types than strings. And so if you have some unusual data type as your column name, you'll have to use that same syntax down here. It's just that by default, the most common case is a string, and strings will not show the quotes in the nice little displays like above. So just expect to need to put strings there. Go ahead and run this df open square bracket hi, we see that we get out what is called a series object. This series object is a lot like a data frame, except it contains only one column of information, although it does still have the index information brought along with it. The first approximation, you can think of a data frame as being a Python dictionary whose keys are column names and whose values are the lists of information for each column available. Now, it turns out there's a lot more rich behavior going on, and the technical implementation is a bit different than that. But the first approximation, this is the first way you should think about accessing data frames and series objects. So we now have our series object. This series object we can treat like a list, and we can access it in a number of different ways. Now, as a true list-like object, we can directly just grab the third element from that list. And if we do that, we can see that, yes, indeed, 5.33 is the third element, remember, starting with 0, and that we are able to pull that specific value. However, we also have this index that's being brought along. So we can take this index and use the index itself. In this case, let's go ahead and take the index from the same position. And we can get the value this way as well. To reiterate, we can use the square brackets on a data frame object to get back a series object where the value we put in is the column. And on a series object, we can use square brackets to access an individual element where the value we put in is either the position along the way or the value of the index. The other way we can do this is we can also use variables. Right? And then it's going to be pretty typical that when you actually do this, you're not going to be manually typing high and low. Usually you're going to have some variable that's being set, or you'll be looping through some list of variables, or doing something a little more programmatic. And what you'll get is something like this. So syntax-wise, it doesn't look that different. It's just that you're not going to see quotes because this is the name of a variable as opposed to the name of a column. That syntax is relatively straightforward. Now, let's say we want to do something a little more interesting, and we want to grab multiple columns of information. So, in this case, we're going to say we want both the open and closing price for our stock. Right? So we can define a variable that has a list containing multiple columns, and then we can go ahead and pull multiple columns of information using square brackets. We run this. We now get back a data frame. So this is a little different than what happened before. Instead of our use of a variable giving us back a series object, we got back a data frame. And this should be really easy to see when you're using Jupyter Notebooks, because it naturally will format data frames in this nice structured way here, these are tables, whereas a series object would look more like a list of plain text. Nothing too surprising has happened here, except now that we've accessed multiple columns at the same time, and hence we need a different data structure in order to return the result. Now, this leads us in the next step to something that is confusing to a lot of people. We could say, oh, well, maybe I wanted to access those multiple columns. Well, can't I just use this syntax right here? And this will give us an error. Why does this not work? Well, first of all, let's look at what the error is. The error here says we have a key error, open, close. Now, it's really tempting when you first see this to think, oh, okay, key error, okay, maybe I understand that. That's trying to match the names of the different columns. I mentioned before, a data frame is much like a dictionary whose keys are column names and whose values are the different columns of data. So a key error here is consistent with that idea that these are column names we're looking for. And for some reason it's not matching up. But we know open and close are valid names for columns. So why is this not working? And the reason it's not working is it's not looking for the open column and the closed column. Instead, it's looking for a column, which is a tuple containing the string open and the string close. We have no such column with this kind of complicated name, and so it fails. When you try to use a square bracket syntax here, like this, you're saying, I want this thing. This thing is not a string, it's some more complicated collection of strings. If you explicitly want it to take in multiple columns, you have to have syntax that looks like this. Right? Now this is a bit confusing to people. Why do I suddenly have this double square bracket syntax when earlier single square bracket, if you look back up here, worked just fine? And the reason for this is that these square brackets mean different things. Now, the Python programming language, like any programming language, only has access to so many different symbols, and so you end up with some reuse of symbols in the language. In this case, we have square brackets that are used to denote I wish to access something, so I'm going to access the data frame and grab something from it. And I have square brackets that we use to denote the definition of a list. Right? So here we had square brackets that were not part of accessing anything, these were defining a list. It's just that instead of defining the list on one line and then using the list on the next line, we define the list on the same line in which we used it. Hence, we end up with a double square brackets. So this is the reason you end up with this syntax that seems a little bit inconsistent on what you're doing, whether it has one set of square brackets or two set of square brackets. It's because you have to decide if you're giving it an item or you're defining a list to give it multiple items. Different people have different ways of handling their confusion around this. One option is you can always just define variables. And this is actually probably a pretty good choice in general because as things get more complicated and you want your code to get more programmatic, this is actually going to give you more flexible code in the long run. However, a lot of times you're only working with, two columns or something relatively simple, and that's one solution right now. And so getting in the habit of just stepping back and saying, okay, am I accessing one thing or two things here, will also be another way of handling this multiple or single square bracket phenomenon. The big takeaway here is that square brackets mean both definition of a list and access to elements inside of a data frame or other structure. And so sometimes you see them back to back because of that. So now that we've used our syntax in order to grab a data frame with multiple columns, let's go ahead and do this to grab, again, our subdata frame, same as above, and put open square bracket 3 after it because we want the third row of information. And this fails. Now we saw earlier we did data frame COL 3. We were able to get back a single value for that single row. Now I get a key error of 3. The reason this is happening is when we did this before with COL, if we run this, we get back 5.33 because the thing we're getting in the first half of this is a series object. And so they can access it as a series object by row. When we have multiple columns and we access it, we get a data frame object, which means we cannot access it by row. We have to access it by column. So you either need to be doing something where you're grabbing a column from this, hopefully without a typo when you write it. Right? Or we need a more advanced method for accessing it. So our next takeaway for today is we need to be careful about keeping track of whether we are creating a series object or a data frame when we're grabbing things. Now here I made a very explicit choice in my variable names for call versus calls. They look very similar at a glance, but I'm being very deliberate about whether I make a single or plural choice here, because that'll help me to remember when I'm looking at the data later on whether I'm expecting something that's going to be a series object or I expect something that's going to be a data frame. Now, let's say we want to actually do something with our data frame and grab a row of information. How are we going to do that? All right, one way we can do that is using the .loc attribute. The .loc attribute allows us to access things on a location basis. So in this case, I can go ahead and grab a name here, copy this, and we'll deal with a typo in 1 second here. So we run this. Okay, and now we grabbed from our data frame, which contained 2 columns, the row that corresponded to this given date, the value of our index. Now you see this actually returns another series object, and this does something a little bit odd compared to what we've seen before, in the sense that the index of this series object is actually the names of the columns in the old one. So be aware that when you do these sort of access things, you're going to sometimes get a little bit strange looking results. Now, this is not the best way to do this, because if you notice what we really did here, we took our original data frame and we grabbed some columns, and then from those columns we grabbed a row. Well, the .loc actually allows us to do both of those things together. So we could get the same result here by doing df.loc of our row of interest, comma, our column or columns of interest together. We get the same result. So rather than doing this in multiple steps with multiple accesses in the data frame, we can make a single query into the data frame using LOC for this specific combination of row or rows and column or columns. Likewise, there's also a similar methodology if you want to do it instead of by name, by position, and this is called .iloc. So if we do .iloc of, say, 2, 4 from our data frame, we're going to get 4.9, which is the value for the second row and fourth column. So together, iloc and loc give us two ways in which to access information from a specific spot in a data frame, either by the names using loc or by their positions, .iloc. Now, this does give us some limitations here. For example, what if I wanted to do the second row, but I wanted to get certain column names? Well, it's not going to work. You can either try using LOC or iloc, but either way you're going to get an error. And the issue is because you're trying to mix indexing by position and indexing by name. And so you can't quite get there directly. And you're going to have to do that as some sort of two-step process, or do some work to predefine the variables so that you can get, for example, the name of the row that's in the second position, so you can plug it into LOC. So one example of doing this that does technically work is you could, for example, do df col.iloc 3. So in this way, we're grabbing a column name, and then we're grabbing a row based on position. Right? And that would work, of course, for multiple columns as well. All right, so now we have some tools for grabbing a little more rich set of information. Let's go ahead and go big. Let's grab multiple rows and multiple columns of information at the same time. So we're going to go ahead and grab two sets of dates here. 20, 05, 18. And we're going to grab two sets of columns, low and high. Right? So just like before, we talked about how you can have multiple sets of square brackets inside each other. And that's all we're doing here, is we're defining a list of rows and a list of columns, and they are inside a set of square brackets that are being used as the accessor for df.loc. We run that. We see this returns a data frame with the exact subset of information we want. Now, building the exact column names you want and row names you want is going to be something you're not going to be doing manually for the most part. It's going to be something that's be a result of some programmatic search. So doing variable names here is going to be far more typical, but you support to not be afraid if you see this syntax that looks very complicated and realize it's just got made up of a few smaller pieces, defining lists, and then a comma to separate those two lists inside a set of square brackets that are our accessor. So we've expanded this syntax up here to take two lists instead of a specific string and a predefined list. And likewise, we can do something very similar with the df.iloc. In this case, we can take, for example, 2, 4, and get, again, a specific single position. Now, here it's good, again, to highlight that we're going to get different return types depending on the way in which we use these LOCs and ILOCs. In the first one here, we gave it multiple rows and multiple columns. That means we had a multi-dimensional piece of information, and so it had to return a data frame to give us that. When we did the ILOC with 2 and 4 here, we only asked for a single row and a single column, so it actually gave us the exact value. We also could, for example, get df ILOC of rows 0 and 1 using slicing syntax, so everything up to 2, and column 4, and if we do that, we'll get a data frame rather a series object, because they have a one-dimensional sort of structure. And likewise, we can do the opposite here for 2, where we're going to grab we're going to have a single row and multiple columns, and again, it'll give us a series object because they're both one-dimensional things. But you'll notice that the way these are labeled are a bit different, because if you have multiple rows, the index is going to be the rows. If you have multiple columns, the index here is previously what was the column names. And then, of course, we can have the general case of accessing it with slices for both the rows and the columns. And in doing so, we get back a data frame object. So the takeaway here is that you need to be aware of exactly what you're asking for in terms of number of items, because it's going to drastically affect the data type you get. And then downstream of that, you're going to have different access methods. Just as we saw, the use of square brackets in a data frame is column-based, in a series is row-based. And if you try to access a value that is not a data frame or series object using square brackets, you're just going to get an error altogether. So you need to keep track of that piece. And we could spend a long time here going through all these different examples and just demonstrating these little pieces here. And this piece of code will be available on GitHub. But the thing that's going to help you understand it is just playing around with it. I would say take 5 minutes, take 10 minutes, open up a Jupyter notebook, and just try to access things with different methods. If you get stuck or confused as part of some bigger code, don't try and get stuck debugging the real thing there. Stop, pull up a simple example, load a little tiny data file like the Ford Motor Company stock prices, and play with some of these access methods until you've disambiguated what it is in your own mind that's causing some confusion on the bigger system. And in this way, you'll get a lot further than trying to memorize patterns and rules if you get a little more skill with simply going through and trying little things to see exactly what they get until you click in your mind that last little piece. Thanks for watching, and a special thanks to those whose donations help fund and sustain creating content like this. As always, the code produced today is available on GitHub through a link in the description. Remember to like, subscribe, push all the buttons, click all the things, and I'll see you next time.